Ever wondered why some musical notes sound harmonious together while others clash? Well, it's not just a matter of taste. There's a science behind why certain combinations of sounds can make your heart soar or your teeth grind. Imagine two musicians playing the same note on different instruments. One is playing a note that vibrates 440 times per second, or 440 hertz. That's an A note. The other musician plays the same A note, but at double the frequency, 880 hertz. To our ears, these two notes sound essentially the same, just one is higher. This is because our brains interpret frequency as pitch. But what happens when these musicians start playing different notes together? This is where the magic, or rather, the mathematics of harmonies comes into play. Certain ratios of frequencies sound more pleasing to our ears than others. For example, when the frequencies of two notes have a ratio of 3:2, we get what's called a perfect fifth. If you've ever heard a cello and a violin play together, you've heard a perfect fifth. It's a warm, rich sound that feels stable and resolved. Another important ratio is 5:4, known as the major third. This is the sweet, happy sound you hear in a lot of popular music. It's the sound of a singer's voice soaring above the instruments in a pop anthem or a tender love song. These pleasing ratios aren't random. They're deeply embedded in the structure of music. In Western music, we divide the octave into 12 equal parts. This isn't the only way to divide an octave. Many types of folk music use a 5-note scale, for example. But the 12-note system works well because it divides neatly by 2, 3, 4, and 6. This makes it easy to find those harmonious ratios. So, in essence, the harmonies that give us goosebumps, that make us want to dance or cry, they're not just a product of a musician's creativity. They're a result of the fundamental properties of sound itself and how our brains interpret those sounds. It's a beautiful blend of biology, physics, and mathematics, all working together to create the music we know and love. Next time you listen to your favorite song, take a moment to appreciate the science that makes it possible. In summary, the science behind musical harmonies is a complex interplay of frequency ratios, octave divisions, and our own biological perceptions of sound. It's a fascinating field that combines the abstract beauty of mathematics with the emotional power of music. So next time you're moved by a beautiful harmony, remember it's not just your heart responding to the music, it's also your brain appreciating the mathematical elegance behind it.